The best name I have for type 3 is story. You like stories? Yeah, read me a story for bedtime, right? My kids love that. Type 3 is that. And so this is the most common. You're gonna see this in grade 12 as well. The nice thing about type 3 is that you actually only have 2 columns, kind of like what we're used to. And so let's go over, and I'm probably not going to finish this lesson today, but I'm going to get you started, and hopefully you can do a few on your own. A scenario where you're provided with 2 points, right? You're provided with 2 points. You have to find the third one using symmetry, okay? And this is, yeah, 71? 71. What did I say? Okay, got it. So 71 for now, yeah. I inserted this new. This is a new for you guys. Maybe this will help you understand. The best way to solve this type is to sketch it first. Sketch it first. I'm not really going to give you, I'm not going to take off marks if it doesn't have all the labels, but just sketch it. Remember, there's usually a third point across the starting point. Okay? Remember that. Okay? And so let's go through some scenarios that you will encounter. So let's say scenario 1, you have a starting point that's first and the vertex, right? So this is the first point, second, and basically you have to find the third one here. So imagine we already sketched this. We read a ball is kicked and reaches a maximum height of 17 feet, maximum height of 17 feet after 1.25 seconds. What is that right there? What would we call this? What point? The maximum height, that's the vertex. That's right. You should recognize that. And let's label it on our sketch here. 1.25 seconds go by to reach that 17-foot height. A lot of students mix these up. They put 17, 1.25. Just got to make sure, right? Time goes x-axis, height goes the y-axis. So you got to put it in the right place. Whoa, there's only 1 point here, Mr. Erickson. I don't see the first point. Never mind the third. Where's the first point here? 0, 0 is the power of 0, 0, guys. It's so helpful. On a provincial exam, there was one like this, and students missed this one. 0, 0, couldn't do it. It's like, I don't know. I only have 1 point. You told me there's 2 given, right? It's assumed that we're kicking it right on the ground, right? Not off the ground, it's right on the ground, unless they would tell us differently. So 0, 0, 1.25, and this is the starting point right here. This is the starting point right here. You can find the one across from it. Okay, right there. What do we know about the y value of that one? 0, same as what I started with. What about the x value? How many seconds does it take to reach the middle? It takes 1.25 seconds, right? So it will take another 1.25 seconds to get to the other side. So basically, we take this and we multiply that by 2. So that gives us 2.5. Okay, 2.5. And you can write this if you want, 1.25. It takes another 1.25 to get exactly back to the point where you started. Same height, I should say, same height as where you started. Okay, so let's do this. We would do time and height, we make our little table. I would strongly encourage you to do this. 0, 0 is given. 1.25, 17 is given, right? Given, given, and this one needs to be found. So we're going to go 2.5, 0, okay? This is the third point. Page 71, okay? And I'm going to highlight this last one here because that's the one we found. So remember, you start at 0, you end at 0. Okay. Next, over here. An object is thrown from a height of 8 meters. Right? Thrown from a height of 8 meters and reaches a maximum height of 13 meters at a distance of 3.5 meters. This is the vertex right here. Let's put that on our graph first. Okay. So the vertex, 3.5 meters, both are meters. So distance is usually known as the horizontal distance, right? So we would put 3.5 meters traveled horizontally and reaches a height of 13 meters. There we go. And we do not start on the ground. We start off the ground. We start here. And what height do we have there? We're told it's a height of 8 meters. And what's the distance at that point? 0, right? It hasn't traveled horizontally yet, right? When it's just about to be thrown, you start at a distance of 0 and a height of 8. So watch carefully. I'm going to highlight that, and I'm going to travel across to this point right here. I'm not on the x-axis, right? Not on the x-axis. Remember that, please, because a lot of students bring a point in here at the bottom. They double the value and they just put it down here. No, it's not true. So that's what height are we at when we're right across? Ocho, right? 8. Why is he speaking Spanish? And this is going to be multiplied by 2.
Good morning. Please excuse the interruption. With student staff versus student volleyball.
That's a good choice. All right. I'm going to keep going. So 7, 8, right? 7, 8. So what we did is we used the axis of symmetry again. We know that this is 3.5 and this is 3.5, all right? That's why I'm multiplying it by 2, but really the coordinate is 7, 8. And I think you should see that. So we would go distance, height, and in this case, we started off 0, 8. The vertex was given. We had to find that other third point, which is across. So you should immediately realize that it's 8. We're coming back to 8. And this is 7, right? So I'll say given, given, and this is my third point right here. So a lot easier to do than the other two types. 99% of the time, you will notice that, right? Oh, I started at 8, I'm back to 8. I started at 0, I'm back at 0, right? So let's keep going. I'm going to try to keep the points there, so if you're behind a little bit, you can still write it down. Okay, let's do this. Scenario 2, start and end point are given, but no vertex provided. You see that? No vertex provided. So you're going to have to figure that out. So this is starting on the ground and off the ground. I kind of categorize them just like before above. An object is thrown upwards, reaches a maximum height of 40 feet, then lands and remains airborne for 8 seconds. Remains airborne for 8 seconds. Okay, so we're not told that we're off the ground, so this would be 0, 0. The object is thrown up. We reach a maximum height of 40 feet. So we know the y variable, the y value of the vertex, but we do not know the x variable, the x value of the vertex just yet. But we do know this point over here. What is this point? 8. After 8 seconds, it hits the ground again. Okay. After 8 seconds, it hits the ground. So again, we're going to use symmetry here to help us out. Instead of multiplying by 2, what are we going to do? We're going to divide by 2, right? So you take your x value of the point that's across the one you started with, and you divide it by 2. So that would be 4. Oh, I'm going to use red, right? Whatever you want, whatever you want. They're your notes, right? Not my notes, they're your notes. Do whatever you want. Okay, 440. So now you have the third point, which is the vertex. So they have to give you the y value for sure, right? For you to be able to do this. Because you cannot, you need to know what is that maximum height. So let's do our table here. This would be time and height again. Time and height, 0, 0, 8, 0. And then we found this one, which was 440, right? So this was given. There's our third point. Which is the vertex. So sometimes it's times, sometimes it's divide. You just need to, if you sketch it, it should make sense to you. It should. Okay. All right, next. The skier goes down a 30-foot ramp, lowest height of 12 feet, and reaches the initial height at a distance of 50 feet. Whoa, what's happening there? Right. Well, it goes a 30-foot ramp. That would be this one here. So this would be at a distance of 0, you are at a height of 30 feet. Then you reach, it says the lowest height is 12 feet. So that is in the indication, right? This is the part of the vertex. Vertex, right? So let's go over here and just go 12 feet. We know that the height is 12, but we don't know the distance that we covered there. It's a bit small, but it should be fixed. And yeah, why not? In this case, I would say it's a bit of code here, code language, right? Where it says that at a distance of 50 feet, right, we reach the initial height. So So 50 feet later, we come back to the initial height. So the skier is kind of going down the ramp, right, and then back up, right? So this is 30 here. So you should recognize, okay, same height here. So I can use these two x values to help me find the middle. So axis of symmetry here. I'm just going to take this and divide it by 2 to get the 25 in here. So now I know that the vertex is 25, 12. So distance and height, 0, 30, 25, 12, 50, 30. And I will highlight the middle one, indicating that that's the third point that I found. So this is given, and third point is found. Technically, I used the red pen earlier just to indicate that's the third. So that would be worth a full mark to find that third point that you need to come up with the equation. So technically, we could come up with the quadratic equation for all of these scenarios here, right? You put this into L1, this into L2, boom, 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 you go find it, right? Let me just see what's on the next page here for you. I was gonna do an example, but I think I'm just gonna stop there, and I'm not gonna assign any new homework here. We're gonna stop here. That way it can simmer a little bit,